Hi everyone, my name is JieWen, and this is presentation of the final project, CSIE63 BigDataAnalytics. The topic is Reduce Subscriber Churn. This problem is to predict churn and find out important features. To prevent it, I'm using Apache Spark machine learning packages to analyze it. So, what is churn? It started in the telecommunication areas when a customer is leaving the company or the business. And now it applied to many different areas. Statistics show that it's really hard to acquire a new customer compared of keeping them, which is called retention. So that makes analysis of churn really important. This project is implemented using Spark and Python and also Jupyter Notebook from Anaconda because we'll plot the ROC curve in the Jupyter Notebook, which we could see in the next few minutes. Spark and Python are installed on the CentOS operating system, and Anaconda was installed on the Microsoft Windows 7. The dataset we retrieved from the IBM website. It is regarding a telecom company, the churn data. It has either a company churn or not, which has around 7,000 records and 21 columns. From this screenshot, we could see that it has customer information, customer ID, gender, either the customer is citizen or not, has partner or not, and has dependents or not, and so on. The last column churn is our label column. It indicates that if the customer has churn, yes or no. And from this spreadsheet, we could see that customer ID is unique. So in the future analysis, for the data cleaning steps, we're going to remove it. For this project, I'll use below steps to implement different machine learning models. First, install required software. After import CSV files to Spark data frame and cleaning steps, we'll use logistic regression. Logistic regression was Lasso. Logistic regression in LastiNet, random forest, and also gradient boosted trees. First, we get the train and test data from data frame and apply different algorithms and packages, and then calculate ROC, accuracy, RMSE to decide which algorithm is better. All of these steps will show in the next few slides with detailed information. Regarding installation and data cleaning steps, we already have Spark and Python installed on CentOS machine. And here we only need to install Anaconda in order to use Jupyter Notebook to plot ROC. And for the data cleaning steps, we remove null values to replace with the mean values. Also, detailed attribute analysis is conducted. For example, here we have a contract versus churn and non-churn. As we could see, it has three values, month to month, 1 year, and 2 year. Month to month here has more churn rate, as shown below screenshots. And also after analysis, we found out that the tenure column has too many discrete values, and most customers has month-to-month, 1 year, 2 year contract. So we're going to use a bucketizer for the tenure column, grouping as 1 month, 2 to 3 months, 4 to 6 months, and so on. In order to make machine learning packages to work, there are two important steps. One is string indexing. The other one is one-hot encoder. String indexing is to change the categorical columns into numbers so that the machine learning packages would identify that. But after that, there are some issues. The column values does not make sense. For example, there's a column called multiple lines. It has a value of no, yes, and no phone service. After string indexer, it showed that no change to 1, yes, it's no change to 0, yes, is 1, and no phone service is 2. This does not mean that 2 as no phone service has a higher value than the 0 as no value. So we're going to use the technology one hot encoder to change it to the vectors, and the results are shown on the left side for the string indexer and one hot encoding. We could see the columns added with underscore encoder after changing. Regarding the different algorithms, we follow the similar steps to analyze churn and make predictions. First, we need to select feature and label column. Here we're going to show that in the CentOS virtual machine. In our case, the label column is churn, and for feature, we're selecting all the columns after the data cleaning steps as our feature. And then we're going to create train and test from this churn prepared data frame. Train is 80% of data and test is 20% of data. We're setting seed as a random number, so every time the output will be the same. After these steps, we're introducing logistic regression model from the PySpark ML classification libraries. And label column is our label, which is churn column, and feature column is all columns. And we're going to train the model after the churn and to fit it and train it. After the trained model, make predictions using the test data. Here we could see there's a label and prediction column. The label is our churn, and the prediction, as we can see, there's a label is 1 and prediction 0 in this case. So how do I identify if the model is working or not? Come back to our slides. We'll calculate accuracy, ROC, and RMSE for this purpose. The accuracy, which is the error percentage. Besides the logistic regression, we've also applied this to logistic regression with lasso, logistic regression, elastic net, random forest, and also gradient boosted trees. These are all classification models. The lasso regression penalizes coefficients and is doing its own variable selection by changing the elastic net parameter to 1, which we could see from my code. And when the elastic parameter is 1, it is lasso, and when 0 is ridge. So the elastic net combines both lasso and ridge to generate better output. Random forest is part of decision trees. It is to reduce the risk of overfitting. Gradient boosted trees also is random for decision trees. Here comes a slide of all the visualization results. ROC curve is created by plotting the true positive rate against the false positive rate at various threshold settings. So the value is more, the better. We're going to show this one plot for the logistic regression ROC in our Jupyter notebook. Here, first, I introduced our churn.csv. It has two columns. One is label column, which is our churn from the test. The other one is a probability column. And ROC is plotted for the logistic regression. We're going to show the values for the Jupyter notebook. Here we could see the ROC curve for the logistic regression, AUC equal to 0.8423, which is a good number in our case. And go back to the slides. These four graphs looks really similar to each other, but if we go down and see the numbers, there's a slight difference. For the logistic regression, it's 0.8423, and logistic regression with lasso is 0.8430. logistic regression in LastNet is 0.8434, and for random forest it's lower, it's 0.83. So we could see that for the ROC curve, logistic regression in LastNet performs the best. In order to reduce churn, we need to identify the important features. So we call the customers who has those features for the retention purposes. We used correlation coefficients and get top 10 attributes, which is tenure, contract, online security, tech support, internet service, online backup, device protection, payment method, streaming movies, streaming TV. And from random forest feature, we got top 10 attributes as contract, tenure, tech support, online security, internet service, total charges, and so on. Comparing those two, tenure and contract are the most two important features for the subscriber to decide either churn or not. Which makes sense because depends on different tenures and contract. As we could see from the attribute analysis, month-to-month customers tend to churn more. And we might want to target them to get higher churn rate, so give them offers to give them and change them to the 1 year or 2 year contract customer to prevent churn. Here comes our summary. As we could see from the previous slide, tenure and contract are the most two important features. And regarding this table, we have applied 5 different algorithms in this analysis. And we've calculated accuracy, ROC, and RMSE to define which model performs the best. We got logistic regression has higher rate of error percentage. ROC compared with Lasso and ElaStandard also lower. And here we could see the logistic regression ElaStandard performs the best. It has accuracy of 18.16%, ROC is 0.843, RMSE is 0.43. Random forest is doing has 21% of error percentage and 0.83 ROC. Usually the decision tree is performing better than the logistic regression, but in our case, since the data towards more linear relationship, I think the logistic regression is doing the best. And among those logistic regression Lasso, and ElaStandard, logistic regression ElaStandard model performs the best among our 5 models. Here is a reference of our image file and Spark book. Please, if you have any questions, please ask me. Thank you for listening.